Hi class, so we continue our study in chapter 3 here, and we are moving into talking about section 3.2, which is all about proving lines are parallel. All right, so we have two objectives in this section. The first thing we want to do is we want to use theorems to prove that two lines are parallel, and I'm going to introduce in this video a lot of theorems to go through, and I'll show examples and how we use them and provide context for them. And then the last thing we're going to do is we're going to use algebra, find the measure of angles needed so that the lines themselves are parallel. All right, so I want to start with the postulate, and these is the parallel postulate. So through a point not on a line, there is one and only one line parallel to that given line. All right, so we have this point P that is not on a line, right? And then we have this other line L, right? What I'm saying here is there's only one line that goes through this point P that is parallel to L. That's all that this is saying. And we use this notation here with this little arrow and this little arrow to denote parallel lines. So there's exactly one line through this point P that is parallel to another line L. Similarly, the perpendicular postulate, through a point not on a line, like that point P, there is one and only one line perpendicular to a given line. So what we're saying here is if I have this point P and this line L, there's only one line that goes through P that is perpendicular to line L. All right, remember perpendicular means that where the lines intersect, they form a 90-degree angle. All right, so we got a theorem here. And this theorem is called two lines perpendicular to a third line. So in a plane, if two lines are perpendicular to the same line, they are parallel to each other. So what I'm saying here is if line M is perpendicular to line T and line N is perpendicular also to line T, then we're able to conclude that it has to be that line M and line N are parallel to each other. And we get that notation. All right, so if it's cut by a transversal here, basically what I'm saying, and it forms two 90-degree angles on each line, those lines M and N are parallel. Another one, the alternating interior angles theorem. If two lines in a traversal form alternating interior angles that are congruent, right, that means they have the same measure, then the lines are parallel. So for example, if you have line L and line M and they're cut by a transversal, well, we're able to say, hey, angle 4 here and angle 6, the alternating interior angles, all right, alternating interior angles, we learned that from last section here, all right, if those two are congruent, then we have to conclude that line L is parallel to line M. That's what we're saying right here. All right, let's do an example. So this is about identifying parallel lines. Which lines are parallel if angles 1 and angle 7 are congruent? And justify your answer. So angles 1 and 7, what you should notice, all right, is there are alternating interior angles related to this transversal and lines A and B. So alternating interior for lines A and B. Now, if they're the same, well, angle 1 and angle 7 are not formed by lines L or by line L. So we concentrate on lines A and B with that transversal M, like I said. All right, they're alternating interior angles. So angles 1 and angle 7 are alternating interior angles, like I said. So if angle 1 is congruent to angle 7, then it has to be that line A and line B are parallel by that alternate interior angles theorem that I just introduced. All right, let's do another theorem. And this is called the corresponding angles theorem. If two lines in a transversal form corresponding angles that are congruent, right, then the lines are parallel. So if we have line L and line M that are cut by a transversal, right, and the corresponding angles here, which is angle 2 and angle 6, are congruent, then we're able to say, you know what, line L and line M are parallel. Another one, this is the same side interior angles theorem. If two lines in a transversal, all right, form side interior angles that are supplementary, that means they sum up to 180, then the two lines are parallel. So if we have line L and line M, right, these are the corresponding interior angles, angles 3 and 6. If you were to take angles 3 plus angle 6, their measure, it sums up to 180 degrees, then you're able to say that line L is parallel to line M. We also have the alternating exterior angles theorem. All right, if two lines in a transversal form alternating exterior angles, they are congruent. All right, that are congruent, then the two lines are parallel. So if we have line L and line M and the alternating exterior angles, angles 1 and angle 7 are congruent, right? They have the same measure, then we can say line L is parallel to line M. All right, another new definition here. So thus far we have learned two forms of proof, all right? A paragraph proof and a two-column proof, that's statement and reason. Right? In a third form called a flow proof, arrows show the logical connection between the statements, right? Reasons are written below these statements. And here we show the same proof as above, but in flow proof form. So let me give you an example. So this is about writing a flow proof of the alternating exterior angles theorem, right? So if I have given that angle 1 is congruent to angle 7, I want to prove that L is parallel to M, and that's that alternating exterior angles theorem. So what we know here, we know that angle 1 is congruent to angle 7. Also, angles 1 and angle 3 are vertical angles, right? Because they're angles formed by two lines that cross each other. Angles 5 and 7 are vertical angles, right? So angles 1 and angle 5 are corresponding angles. Angles 3 and 7 are corresponding angles. Angles 3 and 5 are alternating interior angles here. This is what we know. So what we need one pair of corresponding or alternating interior angles congruent to prove that line L is parallel to line M. So how do we do that, right? We use a pair of congruent vertical angles to relate angle 1 or angle 7 to its corresponding angle. All right, so here's how the flow proof would look. All right, and ultimately what we want to do is we want to prove that line L is parallel to line M. All right, so we're given that angle 1 is congruent to angle 7, all right, and that angle 1 is congruent to angle 3, all right? Those are vertical angles are congruent, we know that. So the flow chart, all right, draws these lines. And what it says here, well then by extension, angle 3 and angle 7 must be congruent. This is substitution or the transitive property that we've talked about. And thus, if corresponding angles are congruent, then the lines are parallel. That's how the flow chart looks. What's given, what we conclude, what our next logical step is, and then what we can conclude. Let's do another example. All right, so determining whether lines are parallel. The fence gate at the right is made up of pieces of wood arranged in various directions. All right, suppose that angle 1 and angle 2 here, right? If you think about that, these look like alternating exterior angles, all right, for lines S and R here. Are lines S and R parallel? Explain. Well, yes, it must be. Angle 1 and angle 2 here are alternating exterior angles. If two lines in a transversal form congruent alternating exterior angles, then the lines are parallel. That's literally what the alternative exterior angle theorem said. All right, let's just do an algebra proof or an algebra problem. So let's use algebra to prove the lines are parallel. So what is the value of x that makes line A parallel to line B? All right, so if two angles are same side interior angles, right, by the same side interior angles theorem, all right, line A will be parallel to line B if the angles are supplementary. Well, what that means is you got to take these two, and when you add up their measure, it has to be 180 degrees. So solving this, we subtract, we combine like terms. Then we subtract the 120 over. We divide by 2. We get x is equal to 30. So a measure of 30 degrees, x is equal to 30, would make these two lines parallel.